Okay, up here I have what's called a system of equations. What are these two equations modeling? That's not my question quite yet. Okay, before we answer this question, what are these two equations? Are they quadratics? No. Oh, they're linear equations. And what are we looking for if I have two lines? We are looking for where they intersect. And two lines, if they intersect, would intersect at a point. So when we solve a systems of equations, we're asking ourselves which coordinate are these two intersecting at. So before we solve it, okay, don't get excited about solving quite yet. There are three ways to solve a system of equations that you've talked about since Algebra 1. What's one of them, Nathan?
Substitution.
We have substitution. This would help. Okay. We have substitution. What else?
Elimination.
What's the third one?
I was thinking of rewriting. Oh, my bad.
I almost call this when you combine it. So it's like the 5x and 2x. You subtract it, and then it's 3x, and then
That's kind of along the elimination lines.
I was thinking if we, since we have an x and a y, we just do a rewrite of like y equals like y minus y1 equals m and like x minus x1. Like point intercept form.
Slope-intercept form's not a bad idea.
Oh, we put in 0 for x and y.
And what would we do with that?
Like find x and y.
Like if we had x and y intercepts, where could we put those?
Okay.
We could graph the two lines and visually see where they intersect. Yeah, usually you start with that when you learn it in Algebra 1, okay? And then you talk about substitution and elimination, okay? So this is what I want. With this problem, do you have it written down? If your pod number is an even pod, I want you to solve this using substitution. If your pod number is an odd pod, you get to do elimination. 1, 2, 3, go.
So pretty much when you eliminate, you just put like subtraction symbols between them, and you can
Which
find
would
like
probably
something
be the
going to
easiest to
be
solve for us?
3x minus
And what would you solve
7y
for?
because it's 3.
Oh, yeah, I remember this.
Well, actually, no, it's
I
plus
remember
7y
having
because
the
I don't want to
yeah,
be
it's
able
a
to
minus and negative,
If you
and
solve
then
for y,
it would be a
Is that because
the way we're doing substitution,
by the end you'll get
we would have to like cancel one out, and then we would have to solve, and then we would plug that back.
So do we just?
We
can
need
remember
to
all of that.
isolate
Substitution.
one.
Yeah, how do you figure out what number to plug in?
Let's go for it.
We're not plugging in anything. We're picking
So,
one of these and
if
we're
we're
solving
for
for one of the variables to plug back in.
y,
So like if I was going to solve for a variable,
one in for
would I
y,
choose the first or the
and
second?
subtract it, and we can solve for it.
I would choose the second one. So maybe x. Solve for x in the second equation.
Okay.
I just remember if you were able to find one, you would do one in. Elimination, elimination. Miss Hellman, for
Yeah?
elimination, is that the one where you try to like eliminate one variable to find out?
Uh-huh.
X equals 2y.
So you make them, you choose x's or y's and you multiply by a number to make them opposites. So you can add them together.
The bottom one I added 4y over. Then 14 and a 4.
I hate
So we have to multiply. We have to multiply. So like 7 or something.
Okay. So this still needs to stay one. So you would have 2x.
Yeah.
Multiply the top one.
Yeah, x equals 7 plus 2 right.
Oh, I.
So then plug in that for x on the first
So we're canceling out.
Wait, are we talking about -2 and negative side?
-2 on the top and 5 on the bottom. 14, 50, 70. So x is cancel.
You can put your work up here on the top.
And then we take
Wait, what's 14?
Then you can plug y back in.
4 times 5 is 70.
Here, we're gonna put the parentheses
Yeah, and then x
on the,
equals
like, so equals 9 parentheses, because you multiply all of it by 4.
Oh
Which is what you have written down.
Yeah. X equals 3.
Yeah, isn't it 18 on this one? It's -18.
Yeah, it's 70 minus 18.
And then you're adding them together, so it's always 18
So like
plus.
bigger number on even if you subtract the bigger number, but then subtract a small number from the big number.
Okay, so 26
So you're
y
just
equals-
combining these.
Yeah.
You're not subtracting.
So
So
you
right
s-
here was -6 y negative 21, so that was -6.
So does y equal -2?
Yeah,
Yes.
and then x equals
Yes.
X equals
So then our
Wait, how did we get how did we get 3?
okay, so then if y equals -2, then you take
Either
one of
these
these and you
oh.
plug -2 for y and then you solve for x. See, that's why I do elimination so much substitution because it's like not bad.
Because it's
Okay, Veronica has her elimination work up here on the board. In elimination, our goal is to get the x's or y's to be opposite. So she looked at this and said, ooh, well, y's are already at least different signs. So if I multiply this first equation by 4 and this second equation by 3, then my y's will now be opposites. And so now if we just combine these two equations, we get 26x, the y's go away as planned, equals 78, so that x equals 3. Then she could take this 3, doesn't matter where she goes.
No.
It's the solution, so it should work in either one to get the same answer. So she just chose the first one. She plugged 3 back in for x to get y is -2. Now, what did I say? This is a coordinate. So I really need your solution to be written as a coordinate. Okay. Those of you who did substitution, are you getting 3, -2? Okay. I need one of my substitution people to come put their work on the board. Emma, how about you? While she's putting that on the board, go ahead and make yourself an XY axis, because we're going to graph them. Okay, so it looks like Emma took the second equation and solved for x. Thank you very much. So she took the second equation and solved for x so that she could take x and plug it into the x in the other equation. So she solved for x in the second, plugged it into x in the first to get the y equals -2. And just like in the other one, we could pick either equation to throw -2 back into to solve for the x. How do you know if you have the right answer? Can you check? You betcha. You can plug it back in. 5 times 3 plus 3 times -2 equals 9. 2 times 3 minus 4 times -2 equals 14. You should know that you have the right answer. Okay? Let's talk about how to graph these. Okay? There are 2 ways to graph a line, and I want to remind you of that. The first way to graph a line, if we take this and solve for y, we would have y equals -5/3 x plus 3. All right, if we solve for y. So we know that our y-intercept is 3, and our slope is -5/3. Rise over run. Right? Okay. I'm going to show you a different method for this one. Are you ready? Okay. I'm going to go off of Veronica's suggestion. Can you plug 0 in for x and 0 in for y and find the x and y intercepts? Yeah. If we plug 0 in for y, what's our x-intercept? Look up here at my hands. If we plug 0 in for y, what's our x-intercept?
7.
Good. If I plug 0 in for x, what's our y-intercept?
3 1/2.
-14/4, right? Which is -7/2, right? Hey. There's our intersections. Okay. Now, graphing is not always the most accurate, especially if we have some sort of rational answer like 1/2, 7/6. Okay, graphing is not going to be very helpful there. Okay, but when we get into our later sections next week, I want to make sure we know how to graph one. Okay? Are we always going to have one intersection? What's our other option?
No intersection.
Okay? If we have 2 lines, we could have one solution. We could have no solution. Or if our lines are the same line, we would have infinite solutions. On the front page, you will have 2 problems that intersect at a coordinate. You will have one that's a no solution and one that's an infinite solution. Okay. On the back side are some additional problems that kind of step it up to the Algebra 2 level. Okay? You have the remainder of our time to work on this. My goal for you, to get done, like everyone needs to get done with the front page for sure in the 15 minutes that we have. But I would ideally like you to get 1 through 6 accomplished, and then 7 and 8 are your homework. Okay? Can we do it?